You might have heard of scientific notation before, but scientific notation is obviously used a lot in science. It's especially useful for either very large or very small numbers. So numbers that would have a lot of zeros in them. You can write it in scientific notation and basically cut out those unnecessary zeros. So functions by reducing the number of zeros, but the important thing is it doesn't change the actual number. So it uses the powers of 10. So basically, if you have something, say you have 80 of something, you can write it as 8 times 10. Now granted, that doesn't really get rid of a whole lot of zeros or anything like that, but that's the general idea behind scientific notation. Okay, so here we have 1 equals 10 to the 0 power. Okay. And then you've got 10 equals 1 times 10 to the first, right? And then 10 to the second is 100, 10 to the third is 1,000. So with the positive exponent, basically you take whatever number is times 10 and then just add that number of zeros behind it. So if it's, say, 5 times 10 to the first, it's 50, because you add 1 0 behind that 5. If you have, say, 6 times 10 to the second, you're going to add 2 zeros behind that 6. So it becomes 600. Okay? Now, with a negative exponent, it's a little weird. So instead of adding zeros after that number, you're going to add them before. Okay? And you're going to move the decimal point. Alright, so if you have 5 times 10 to the negative first, you're going to move the decimal point 1 place. So 5 times 10 to the negative first becomes 0.5. Okay? And then with, say, 6 times 10 to the negative second, you're going to move the decimal point 2 places. Right? So it becomes 0.06. So on and so forth. Okay? So scientific notation, when it's written correctly, is written so that only one digit, one number, remains left of the decimal point. Okay, so 45.236 is not, or times 10 to the third, is not incorrect scientific notation. Okay, it has to be, say, 4.5, yada, yada, yada. Okay. It can't have more than one digit to the left of the decimal point. Any non-zero numbers are written in the order that they originally appeared to the right of the decimal point. If you have what are called trailing zeros that are left at the end, okay, you don't have to include them, right? Any zeros that are between non-zero numbers have to be included. They are placeholders, okay? But, yeah, so the number of places the decimal point moves is written as the exponent. If you move the decimal point to the right and you're adding zeros to the right side of the number, it's going to be a positive exponent. If you're moving the decimal point to the left and the number is getting smaller, then it's going to be a negative exponent. Okay, so a positive exponent means the number is large. Negative exponent means the number is small, so less than 0. So, I've got an example here, okay? Not really number of zeros that you'd like to write over and over and over again. Okay, so this is a perfect example of wanting to get rid of some of those zeros. All right, so you'll notice that we have 12 zeros here. Okay, well, no, sorry, 11 zeros. There we go. But because the decimal point has to end up just to the right of the first digit, okay, the decimal point is going to have to end up right here. All right, so you are going to have to move the decimal point 12 places. All right, but then because it's a large number, your exponent has to be positive. So you're moving the decimal point 12 places. It's a large number, so your exponent is positive. So this number here can be written as 4.5 times 10 to the 12th meters. Okay, now if you plug that into your calculator, if it will actually do all of those zeros, okay, you'll find out that this number is the exact same as this number. Okay, they're equal. It's just a little bit easier to write 4.5 times 10 to the 12th than it is to write 11 zeros. Okay, so it also saves some space for you. All right, converting a number out of scientific notation reverses that process. So you add the zeros back in. Okay, it also means writing things in scientific notation also means that you're not going to accidentally drop a zero somewhere. You're not going to misplace it, basically. Right? So if we have 3 times 10 to the 8th meters per second, okay, means that this is a large number, so we're going to move the decimal point to the right, all right, and we're going to move it 8 spots over, all right? So basically you're going to do the 3 and then 8 zeros, right? So you end up with 300 million. Exponent is plus 8, so the decimal place moves 8 places to the right to make a larger number. But again, 3 times 10 to the 8th is equal to 300 million. So the important thing about scientific notation is to remember you're not changing the value of the number. Okay? You're just changing the way it's written so that it's slightly easier for you to write it and there's not as many mistakes made. Okay? Now, this is a perfect example of why we use scientific notation. You have, you have an exponent of negative 25 here, which means that you have 24 zeros in this number, okay? And, writing that many zeros over and over again would just get incredibly frustrating. So this is a much easier way to write it, all right? But remember, because this number is smaller than 1, you're going to have 24 zeros, but the decimal point has to end up between this 9 and the first 1 here, okay? Which means that you're moving the decimal point 25 places, all right? So you have 24 zeros, but you move the decimal point 25 places, okay? So then it's 9.11 times 10 to the negative 25th. In this example, okay, again, we have a number that's less than 1. So your exponent, you already know, is going to be negative. Okay, and then when you look at this, you have 8 zeros. Okay, 2, 4, 6, 8. And then you also have to have the decimal point end up between the 5 and this 0 here. So you're going to move it 8 places. Right? And again, because it is a number less than 0, the exponent will be negative. So it's 5.0084 times 10 to the negative 9th. Right? Now, these zeros, remember, you do have to keep them because they are between two non-zero numbers. But if we had another 0 sitting after the 4 here, you wouldn't have to write that. Okay? Because that one doesn't really matter. It's just kind of hanging out. It's there. Okay? All right, so that is it for this part.